The year is 2154. Our planet has been ruined by environmental catastrophe. In the movie Avatar, greedy prospectors from Earth descend on the world of an ancient hunter-gatherer people named the Na'vi. Their home is a lush moon far beyond our solar system named Pandora. Could such a place exist? And could our technology and our appetite for exploration one day send us hurtling out to reach it? In fact, the supposed site of this fictional solar system is one of our most likely real interstellar targets, until a better destination turns up. Pandora orbits a fictional gas planet called Polyphemus. Its home is a real place, Alpha Centauri, the brightest star in the southern constellation of Centaurus. At 4.37 light-years away, it's part of the closest star system to our Sun. Alpha Centauri is actually two stars, A and B. One slightly larger and more luminous than our own Sun, the other slightly smaller. The two stars orbit one another, swinging in as close as Saturn is to our Sun, then back out to the distance of Pluto. This means that any outer planets in this system, anything beyond, say, the orbit of Mars, would likely have been pulled away by the companion and flung out into space. For this reason, Alpha Centauri was not high on planet hunters' lists, until they began studying a star 45 light-years away, called Gamma Cephei. It has a small companion star that goes around it every 76 years. Now it seems it also has at least one planet. That world is about the size of Jupiter, and it has planet hunters excited. Perhaps 2/3 of all the stars in our galaxy are in so-called binary relationships. That means there could be many more planets in our galaxy than astronomers once assumed. At least 3 teams are now conducting long-term studies of Alpha Centauri, searching for slight wobbles in the light of each companion star that could indicate the presence of planets. If they find a planet that passes in front of one of the stars, astronomers will begin intensive studies to find out what it's like. One of their most promising tools will be the James Webb Space Telescope, scheduled for launch in 2014 or 2015. From a position 1,000,000 miles away from Earth, it will deploy a sun shield the size of a tennis court and a mirror over 21 feet wide. The largest space telescope ever built, it will offer an extraordinary new window into potential solar systems like Alpha Centauri. With its infrared light detectors, this telescope will be able to discern the chemical composition of a planet's atmosphere. And perhaps whether it harbors a moon like Pandora. One prominent planet hunter predicted that if a habitable world is found at Alpha Centauri, the planning for a space mission would begin immediately. Here's that star duo seen by the Cassini spacecraft, just above the rings of Saturn. To actually get to this pair of stars, you'd have to travel as far as the orbit of Saturn, then go another 30,000 times further. Or put another way, if the distance to Alpha Centauri is the equivalent of New York to Chicago, then Saturn would be just 1 meter away. So far, the immense distances have not stopped us from launching missions into deep space. In 1977, the twin Voyager spacecraft were each sent on their way aboard Titan III Centaur rockets. After a series of gravitational assists from the giant outer planets, the spacecraft are now flying out of the solar system at about 40,000 miles per hour. They're moving so quickly that they could each whip around Earth in just 45 minutes. twice as fast as the International Space Station. Voyager 1 has now traveled over 110 astronomical units. That's 110 times the average distance between Earth and Sun, or about 10 billion miles. But don't hold your breath. If it was headed in the right direction, it would need another 73,000 years to travel the 273,000 astronomical units to Alpha Centauri. When it comes to space travel, we've yet to realize the dream forged by rocketeers a century ago. A Russian schoolteacher, Konstantin Tsiolkovsky, inspired generations of space visionaries with sophisticated ideas about multi-stage launch vehicles. He imagined the construction of space stations in Earth orbit, and eventually vast permanent space colonies. In time, he predicted, we'd evolve into a whole new species, Homo cosmicus. Since then, rocketry's greatest advances have centered on ways of containing explosive propellants and methods of maintaining stable flight at high speeds. The problem is that chemical rockets are just not efficient for long-distance space travel. To reach the speed needed to enter orbit around Earth, 17,500 miles per hour, the space shuttle must carry 15 times its weight in fuel. And that's efficient compared to some other rocket systems. And you'd need to be traveling more than 25,000 miles per hour to break free of Earth's orbit and go anywhere else. A NASA study showed that to send a space shuttle-sized craft to Alpha Centauri in 900 years would take an unbelievable amount of fuel, 10 to the 137th kilograms of rocket propellant. Suffice to say, it's more mass than is in the entire visible universe. While only a very tiny percentage of NASA's budget goes to advanced propulsion, there are some promising ideas on the drawing board. Rockets powered by nuclear fuel, or plasma, a supervolatile gas. Huge sails pushed along by the pressure of photons from the sun. Ion drives. But to reach Alpha Centauri within a human timescale, we'll have to go with the most potent fuel in nature that we currently know. It's the science fiction fuel of choice, antimatter. In James Cameron's Avatar, hybrid nuclear fusion and antimatter engines power a mile-long interstellar spaceship. At a speed of 670 million miles per hour, this vehicle makes the journey to Alpha Centauri in just 6 years. Antimatter really does exist, as the mirror image of the universe we know. It consists of electrons and protons, but with their electrical charges reversed. Whenever it comes into contact with normal matter, the two annihilate each other in a ferocious blast of energy. Large amounts of antimatter were created and destroyed in the fiery dawn of our universe, the Big Bang. But somehow, in one of the great mysteries in science, we were left with a universe whose visible substance is almost all normal matter. The universe still produces antimatter through powerful collisions, such as a jet from a black hole slamming into a cloud of gas. When matter and antimatter obliterate one another, they emit gamma radiation that we can then detect with instruments such as the Fermi Gamma Ray Space Telescope. Fortunately, black holes aren't the only way to generate antimatter. In giant labs, like the Large Hadron Collider, scientists accelerate atoms to nearly the speed of light and blast them together to expose their fundamental constituents. Small amounts of antimatter can be made this way, but it's incredibly expensive. With a dedicated facility, the cost of producing it might come down far enough to produce usable amounts. And that's the hope of one researcher. Dr. Gerald Smith has been working for over a decade to find a way to trap this volatile substance and store it in isolation from the rest of the universe. Smith and his colleagues have designed a trap the size of a cigar case. It sits within a tank filled with liquid nitrogen and liquid helium, designed to cool it down to 270 degrees below zero. Once injected into this trap, antimatter particles are suspended by magnetic fields within a vacuum as empty as deepest space. But the problem is that anti-electrons, called positrons, tend to repel each other explosively. That makes it tough to store more than a few at a time. This team now believes it may have discovered a pathway to storing large amounts over longer periods of time. Their solution lies in combining positrons with electrons, forming an element called positronium. In theory, with the right magnetic fields, these electrically neutral atoms might be held indefinitely. When released under controlled conditions, ultra-high energy antimatter beams could turn out to be ideal cancer killers, or lead to revolutionary industrial applications. Or perhaps, one day, they could power long-distance spaceflight. It wouldn't take much. Antimatter is so potent that it defies common sense. A chunk the size of a small coin could propel the space shuttle into orbit. Smith estimates that once in low Earth orbit, a human mission to Mars would take as little as 10 milligrams worth. The basic idea of an antimatter rocket is simple. A beam of positrons is released into the engine core, where it annihilates the surface of a metal plate. That creates an explosion that propels the craft forward. Another design uses a sail. A cloud of antimatter particles reacts explosively to its surface, propelling it forward. Short of traveling to another solar system, there may be good reasons to contemplate developing antimatter propulsion. A preliminary mission would speed beyond the orbit of Pluto, sending back close-up images of dark planet-like objects that ring the solar system out in the Kuiper Belt. A longer distance probe could reveal new details about the Oort cloud, a vast realm of comets that envelops the solar system. Once out there, it could sample particles that make up the interstellar medium, or send back unique data sets on dark matter, the invisible stuff that makes up the overwhelming portion of our universe. To make it all the way to Alpha Centauri within 50 years, an antimatter probe would have to gradually accelerate to around 10% the speed of light. That's 67 million miles per hour. It would then gradually decelerate as it approached its destination. At those speeds, hitting even a grain of dust could destroy the spacecraft, so it might be best to slow the journey down to a century or more. It's safe to assume for now that we would only send a probe to Alpha Centauri if we discovered a habitable world. There may be other choices in our solar neighborhood. They include Proxima Centauri, a red dwarf star 4.2 light-years away that may be gravitationally bound to Alpha Centauri. Beyond that, not quite 6 light-years away, is Barnard's star. Or there's Lalande 21185, a red dwarf 8.3 light-years away. we already know it has 2 Jupiter-sized planets. There are at least 22 stars within 12 light-years of Earth. And any way you look at it, the first interstellar voyage will be a quantum leap for humanity. The urge to reach out to distant horizons, to climb the highest peaks, to push ourselves past our perceived limits, seems to be a vital part of what makes us human. Yet, explorers of old set off not just because it was there. At times it was greed, hunger, fear, or despair that propelled them outward from their homelands and allowed them to endure their long journeys. Whether we attempt to make this leap to the stars may come to depend on how we regard this planet. To the physicist Stephen Hawking, the journey is imperative. "I don't think the human race," he said, "will survive the next 1,000 years unless we spread into space. There are too many accidents that can befall life on a single planet." Indeed, we can't foresee the impact of wars, social upheaval, or the course of human civilization in coming centuries. But today, we can see the often conflicting trends that could one day propel us out into the interstellar void. On one hand, the technological advances that might make such a mission possible could revolutionize many other aspects of life on this planet. The ever-increasing rate at which numbers of transistors can be placed inexpensively on computer microchips has become a metaphor for the advance of all technologies in this century. From a few thousand transistors on the first printed circuits of the 1970s, computer chips now have billions etched onto their surfaces. Even that number could seem amazingly small in another few decades. Many observers forecast a steep rise, even an acceleration, in the pace of invention and basic research, and for whole new solutions to the problems of energy, food production, health, and more. On the other hand, major periods of scarcity may loom. In the 20th century, the world saw the largest increase in its human population, from less than 2 billion up to 6 billion. The world's population is now around 6.8 billion. It's expected to reach 9 to 10 billion by the year 2040, with the biggest gains in Asia and Africa. According to a recent UN report, the world will have to produce 70% more food by the year 2050, and at least that much more energy to sustain its population. The scarcity of just simple clean water in some regions is already frightening. Now throw in environmental impacts, like rising sea levels, or the spread of deserts linked to a gradually warming climate. The culprit, to most scientists, is rising emission of greenhouse gases like carbon dioxide since the start of the Industrial Revolution. This map charts rising temperature readings from the year 1885 through to the present. In some places they've gone up by as much as 2.5 degrees Fahrenheit. Computer models project the trend out to the end of this century. Depending upon population growth, energy use, and conservation, temperatures could rise anywhere from 2 to 11 degrees more. Will technological advancements allow us to halt the degradation of our natural environments and increase the carrying capacity of our planet? Will we find ways to mitigate the impacts of war, natural catastrophes, or political upheavals? No doubt, if or when we launch our first mission beyond this solar system, the occasion will spur reflection on who and what we have become as a people, as a planet, just as the first missions to the moon and our neighboring planets once did. At first, we'll send a probe designed to relay basic information on what's there. on a world whose light we have only studied from afar. As this cosmic emissary makes its way across the void, we on Earth will continue to struggle in our pursuits of happiness and prosperity, or of mere survival. When it arrives, we'll scan the data for evidence of a world like our own, one that may harbor life. How will our perspectives on that world, and upon our own, have changed?
Not since Galileo invented the telescope over 400 years ago has our view of the universe been so transformed. In April 1990, astronauts stationed the Hubble Space Telescope in orbit, above the blurring effects of Earth's atmosphere. Born when pressure and heat in its core cause hydrogen gas to undergo nuclear fusion. The heat generated by this process pushes outward, countering the inward pull of gravity. From the violence of their birth, most stars spend their lives shining in relative peace, gradually using up the hydrogen fuel that makes up their cores. Smaller, cooler stars are incredibly. The Sun has gone through half its expected lifespan. By observing stars similar to the Sun, scientists now have a good idea of what will happen to our solar system in the distant dynamic structures. Take the Ring Nebula, just over 2,000 light-years away from Earth. From Earth's perspective, it looks like a simple elliptical body with a fuzzy boundary. But Hubble observations show that the nebula is shaped more like a distorted donut. The donut hole may look empty, but it is full of lower density gas that stretches toward and away from us, creating a shape a little like a rugby ball that's been slotted into the donut's hole. The space surrounding the nebula is turbulent and full of knotty structures that formed long ago. If we were able to rotate the Ring Nebula by 90 degrees and view it side-on, it would look more like the nebula M76, also known as the Little Dumbbell. A rare and extremely violent breed. Stars 10 times the mass of our Sun, and even larger, burn hot and fast. Intense temperatures and pressure ignite nuclear fusion reactions in their cores. Million-odd stars in our galaxy. One goes supernova about every century or so. The last one to be seen in the Milky Way was observed by the astronomer Johannes Kepler in 1604, just 5 years before the invention of the telescope. The most famous supernova in recent years appeared in 1987 in the Large Magellanic Cloud, a dwarf galaxy just above the plane of the Milky Way. It was so bright, it was visible to the naked eye. Launched 3 years later, Hubble has been tracking the evolving spectacle for over a quarter of a century. Astronomers have marveled at the complexity of the explosion, including the patterns etched by its expanding shockwave. Even though a supernova is only bright for a short period of time, the dusty clouds it leaves behind can last for millennia. Their effect on the surrounding interstellar gas lasts even longer. Although no supernova in our galaxy has ever been observed with a telescope, plenty of supernova remnants have been. Hubble's sharp images of their complex structures help explain the sequence of events, as well as the profound impact these explosions have on the galaxy. absorb visible light. These solid particles are crucial for the formation of solar systems. Within the Crab Nebula, there is enough dust to make 30 to 40,000 Earths. Galaxies all around the wider view, the luminous Tarantula Nebula stands out from its host galaxy. It is the brightest known star-forming region in the local universe and one of the most attractive spots in the night sky. Thanks to Hubble, there is a place within our own galaxy where you can see not only stars, but solar systems being born. In the constellation of Orion the Hunter, just under the three stars that make up atmosphere are buoyant. Starlight passing through the planet's atmosphere. Astronomers are looking for a hydrogen-carbon compound called methane. On Earth, it's produced by a combination of natural and man-made sources, including fossil fuel production and livestock. On this hot Jupiter, methane is probably produced by a complex chemical process in its atmosphere. Astronomers plan to use data to identify prebiotic molecules in the atmospheres of planets in the habitable zones around other stars, where more moderate temperatures would allow liquid water to flow. The new measurements are an important step toward the ultimate goal of identifying the conditions such as temperature, pressure, winds, clouds, and chemistry on planets where life could exist. Astronomers have detected a wide range of planets around other stars by looking for clues, like the wobbling motion of a star as a planet orbits it, or a star getting dimmer as a planet passes in front of it. Hubble was able to capture for the first time a direct image of a planet. Visible from the southern hemisphere, Fomalhaut is relatively close, at around 25 light-years away. It is 15 times brighter than the Sun and much hotter. This star is blazing through its hydrogen fuel supply at such a furious rate that it will burn out in only 1 billion years, 10% of the lifespan of our star. Its most interesting feature may be scientists created a movie from data collected over several days during January and March 2009, when the rings appeared edge-on and both poles were visible to us. The Sun emits a wind of particles that reaches all parts of the solar system. When this electrically charged stream gets close to a planet with a magnetic field, like Saturn or the Earth, the field traps these particles. The magnetic field is stronger at the poles, so the particles tend to concentrate there, where they interact with atoms in the upper layers of the atmosphere. That's what creates the familiar nighttime glow we know as the northern and southern lights. Saturn's auroras are not only charming features, but they might teach us something about our own planet and its magnetic field. Beyond Saturn's dancing lights, or the sudden explosion of a star, the universe appears unmoving against the ponderous march of cosmic time. Among its greatest achievements, the Hubble Space Telescope has been able to track the large-scale motions of the universe. Take an event close to home. Astronomers have long known that the Andromeda Galaxy, currently 2.5 million light-years away, is moving toward our Milky Way. A team of astronomers used the Hubble Space Telescope to find out how fast the two galaxies are moving and whether there will be a head-on collision. If you could wait a few billion years, galaxies each have hundreds of billions of stars in them. The stars are all relatively far apart. The chance of any two colliding is extremely small. Our Sun, born in the Milky Way almost 5 billion years ago, will follow a new path as it orbits a whole new galaxy. In the universe according to Hubble, galaxies all across the cosmos are circling each other, merging, and moving into ever larger and denser groupings. Using Hubble to survey patterns of galaxies, scientists have been able to map a mysterious substance that envelops galaxies and clusters of galaxies. This so-called dark matter adds to the gravity of these structures and has been driving their collapse over time. Because of the arrangement of galaxies, astronomers have long known that dark matter stretches out across the cosmos in a vast web-like structure. Actually observing this web has been difficult. Now, a team of scientists has used Hubble to make detailed observations of a dark matter filament, measuring its length, shape, and density. Theories say galaxy clusters form where filaments of the cosmic web meet, so the team focused Hubble on one such cluster with a stream of galaxies moving into it along several filaments. The astronomer the cosmos. Will its gravity be enough to cause the universe itself to crash together in a heap at some point in the distant future? To find out, they searched for a type of exploding star that's visible across the cosmos. It is the product of a small burned-out star called a white dwarf that orbits a larger star. The smaller star pulls matter from its neighbor, thereby gradually increasing its mass. Finally, when it reaches a critical mass, it undergoes a thermonuclear explosion. These so-called Type 1a explosions are thought to all have the same intrinsic brightness. How bright they appear to us is a measure of how far dark energy.
The entire money-structured and materialistic-oriented society is a false society. Our society will go down in history as the lowest development in man. We have the brains, the know-how, the technology, and the feasibility to build an entirely new civilization.
It was living through the 1929 Great Depression that helped shape my social conscience. During this time, I realized the Earth was still the same place. Manufacturing plants were still intact, and resources were still there, but people didn't have the money to buy the products. I felt the rules of the game we play by were obsolete and insufficient. Misery, suffering, and war provided the incentive for my life's work. I was also motivated by the seeming incompetence of governments, the academic world, and the lack of solutions offered by scientists. I realized instead of working with individuals, a more effective method would be to redesign the culture. This began a lifelong quest to finding solutions to the many problems that we have today.
This presentation is a feasible plan for social change that works toward a peaceful and sustainable global civilization where human beings, technology, and nature coexist. It outlines an alternative to strive for, where human rights are not only paper proclamations, but a way of life. It is called the Venus Project. Its founder, Jacques Fresco, calls for a straightforward redesign of the culture in which war, poverty, hunger, debt, and unnecessary human suffering are viewed not only as avoidable, but totally unacceptable. It is becoming increasingly obvious that anything less will simply result in a continuation of the same problems we face today. The Venus Project's Research Center, constructed by Fresco and Roxanne Meadows, is located in Venus, Florida. It addresses many of the root causes of our difficulties. But what are the real origins of our problems? At present, we are left with very few alternatives, since we're on a collision course of our own making. Answers from yesterday are no longer relevant. Considering the damage already done to the environment, we are rapidly approaching a point of no return, where nature will dictate the course. Either we continue as we have, with outmoded social customs and habits of thought, thereby threatening our future, or we apply a more appropriate set of values, relevant to a sustainable society, with more opportunity and freedoms.
Americans have been conditioned in their kind of society to get a different kind of car next year, to buy a new television set or a tape recorder. We are radical as hell, but our political and social institutions have not changed. And this is where we are stagnating, because we always equate any new idea with communism or regimentation, because we've been brought up to fear that which is new.
None of the world's economic systems, socialism, communism, fascism, or the free enterprise system have eliminated the problems of elitism, nationalism, racism, and most of all, scarcity. These are all based primarily on economic disparity. When money is used to regulate and distribute resources for profit, and people and nations are out for themselves, they will seek advantage at any cost. They do this by maintaining a competitive edge, or through military intervention. War represents the supreme failure of nations to resolve their differences. From a strictly pragmatic standpoint, it is the most inefficient waste of lives and resources ever conceived.
Most wars are for the control of resources and maintaining your position of differential advantage. They're not based on the dignity of man. They're not based on elevating human beings. It might elevate the human beings in the country that's the victor. It might do that. But as far as the rest of the world goes, the price is enormous.
This crude and violent attempt to resolve international differences takes on even more ominous overtones with the advent of computerized nuclear delivery systems and deadly biological and chemical weapons. Yet it is a windfall money-making opportunity for those who profit by the military-industrial complex. If the profit were taken out of wars, do you really believe we would have them?
If they draft you into the army to serve this country, you put up your life for this country, they should draft all the war industries. Every cannon maker, machine gun maker, automobiles, jeeps, warships, all drafted, so that on the same basis of pay as the army. Then it's real. But if you make millions selling warships, machine guns to the army, then it's corrupt. I would, if I had my way, if we had millions of men in the army, I'd send them to school to become problem solvers, how to get along with other nations. That's what we have to do, not kill. When soldiers are just killing machines, they're trained to kill. I would train them to be able to go to Mexico and bridge the difference, and go to the Arab world, see if they can bridge the difference. So bring them all together, all the nations.
War is not the only form of violence imposed upon people. There is also hunger, poverty, homelessness, and unemployment. The acceptance of these conditions as expressive of human nature is a myth used to keep things as they are.
Genetics has nothing to do with greed, business, race prejudice. All of the operant systems in any society are part of your education, the books you read, the role models you follow, and the people you admire. The genes have nothing to do except with the color of your eyes, the shape of your nose, perhaps inherited features. The genes do not control values. And even if you're born with a much better brain than another person, meaning better receptors, the quality of the tissue is better, I would say that if you have a better brain and you live in a fascist country, you become a fascist faster. The brain has no mechanism of discrimination. The brain can't tell you what is relevant or less relevant, except experience.
We are not born with greed, envy, hatred, or bigotry. Our behavior and values are reflective of the culture we are exposed to.
If you were raised by the headhunters of the Amazon, you'd be a headhunter. And if I said to you, doesn't it bother you to have 5 shrunken heads? You say, yes, my brother has 20. So, is he nuts? No, that's normal to his culture.
Social and environmental problems will remain insurmountable as long as few nations control most of the Earth's resources, and the bottom line is profit over the well-being of people. Putting profit first results in unnecessary suffering and aberrant behavior prevalent today. Many people feel that we need the rule of law to eliminate our problems. We have many laws, thousands upon thousands of them, but they are constantly being broken. Paper proclamations and treaties do not alter the facts of scarcity, deprivation, and insecurity.
You can predict the shape of the future and the values if you know the trends of events in the ocean pollution, the scarcity of arable land. If you watch that degrading system grow, I can predict the riots and killing and assassination. In other words, human behavior is really generated by the surrounding environment. If there's a scarcity, say, of water, it is prized, and its price is high. Let's discuss scarcity as a system. Suppose it rained gold for about 3 days, gold dust. People would go out and shovel it in, fill the cellars, the attic, every drawer in the house. They throw out their clothing. If the rain kept up for a year, so the gold was all over the place, people would sweep it out of the house, take their rings off, throw them away, and so human behavior, and it goes, change to that condition. There's only a policeman in front of something that people have need for. and don't have access to. So you put a guard there. But if lemon trees or orange trees and apple trees grew all over the place, you couldn't sell it. If you landed on an island that was so abundant with resources, you had 10 people, there were 1,000 fish for every person if you wanted it. There were 10 times the amount of bread, fruit, and bananas. Money would not come into existence. Private property would not come into existence. If the island was big enough, there was 10 people, there were 8,000 acres. No one would give a damn about staking out this particular area. There are patterns of behavior that promote survival. There are social conditions that change our values and outlook. No one can write a constitution of required behavior without consulting the environment. So we'd better take care of the environment, we'd better take care of one another, and we'd better educate people to the highest possible levels of our ability in order to have a society.
Even a peace treaty cannot prevent another war if the underlying causes are not dealt with. Maybe what is needed are ethical people in government who will work towards everyone's well-being. But even if the most ethical people were elected to high positions and we ran out of resources, there would still be lying, cheating, stealing, and corruption. It's not ethical people that are needed, but rather a way of intelligently managing the Earth's resources for everyone's well-being. Let's examine our social arrangements further. To maintain our economy, products must continuously be sold. To assure this, they are deliberately designed to wear out and break down. Maybe you've noticed this usually happens right after the warranty expires. This corrupt practice is referred to as planned obsolescence, which is the conscious withdrawal of efficiency. Innovators go through the finest schools and then are required to design things that wear out and break down right on schedule. This results in a tremendous waste of resources and energy. We are plundering the planet for profits. If you think about it, it isn't a job people want, but access to what their paycheck will bring. Money does not represent anything real, and there's no gold, silver, or resource to back it up. You can't eat money or build a house of it. It's not even related to our real capacity to produce goods and services on this planet. The monetary system has been handed down from centuries ago, and we continue to use it without questions.
This system will keep installing more and more automation, cutting down on the purchasing power of the majority of people. There will come a time called the Gaussian curve, where employment is that, production is this, and purchasing power is that. The system stops. Banks fail, nothing works anymore. We're moving in that direction very rapidly.
We have finally gotten to a place in 2011 where it's becoming obvious that the machine has beaten the man.
We're incredibly productive with far fewer people.
We are more productive. We are more productive as an economy than ever before.
An
but
iPad
that means
app
we
can
need
do more
less
than
workers.
4 people.
Just that there are fewer jobs. The jobs that do exist now can have lower wages because, for obvious reasons, a lot of people looking for a small number of jobs. The wages go down. That has huge impacts on the middle class and ripples out from there.
We're moving towards social collapse. I think this is going to happen all over the world, not just here. And it doesn't require the overthrow of the government. It just requires that you let it alone. It'll overthrow itself. If you control the media, you can calm people down. But if the majority keeps getting laid off, they don't have purchasing power, the system collapses. It doesn't work anymore. They invade. It's already happening. This country is already insoluble. They're going to have difficulty with national security, paying pension people. They've spent far beyond what they already have. Now, all they can do now is create debt, borrow more and more money from banks.
We also want to show you a rather grim sign of our times. It's not far from here in Midtown Manhattan. The national debt has grown too large for the national debt clock. It went up back in 1989 when the nation's debt was less than $3 trillion. The debt has been piling up so fast lately they had to drop the dollar sign to make room for an extra digit as the number turned over to more than $10 trillion now and counting every second. A whole new clock with 2 extra spaces will go up next year.
The federal government is not allowed to print money. It's not allowed to lend money or get in the banking business. That is a privilege for bankers only. So what the government has to do if they want to build an air force, say, of 2,000 planes a month, they have to borrow money from a private lending institution, sign the dotted line, and if the war is lost or failed, the burden falls on the public to pay off that debt.
We find ourselves and our social constructs in a transitional state, a matter of social evolution. If we want to make it through these turbulent times, we must be